Karthick, can you, Karthik, keep your screen ready. All right. Karthik,
Is it visible?
can you, Karthik? No, I keep your screen ready. All right. Karthik,
Is it presenting?
I can see now, Muthu.
So you see the Google Meet screen or the presentation?
Sorry. I can see your desktop.
Okay.
So can you just open the PPT, the first one?
Yeah. So
Yeah, no, just open the first PDF, the one which you have downloaded. Yeah, and make it
yeah.
full size.
Yeah.
All right.
Yeah.
Good afternoon, and actually, now we will start the session, and we have three speakers. First one is Dr. Muthukaruppan from Sosaley, and he completed his MS degree in Germany in the title of biomedical instrumentation, and his PhD in the field of medical imaging in Netherlands. He has more than 10 years experience in biomedical engineering. And our next speaker is Mr. Anoop Prasanna. He is the Assistant Vice President of Sosaley, and he's in the sales in charge. And he completed his master degree in the Master of Business and Engineering. He's have more than 10 years experience in the field of medical. And final honors, Mr. Karthick, I am very proud to see he is my student, and he's a sales engineer of Sosaley. He's completed his master in BME, and he has more than 5 years experience in the field of biomedical. Now let us start the session. Sir, Dr. Muthukaruppan sir, please you will start the session now, please.
Thank you, ma'am. Thank you, ma'am, for the introduction. And now our AVP Anoop will start with a small corporate presentation of our company, and then I will take over from it.
Okay, sir. Good.
All right. So Muthu, could you just share the screen? Move on to the first slide. All right. A very warm welcome to all the participants and folks. Very good afternoon. And so here we go. So we are from the company called Sosaley Technologies, and you can move on to the next slide, Muthu. All right. So we started in the year 2008, and initially, we were purely into product development. So for first 4 years down the line, we were into product development. So depending on the market scenario, we used to do a product right from the scratch to the production. So more of all the products what we have been developed, it's been designed and developed by our own company. So we own the IP. And later stage, you can move on to the next slide. Slide number three. Just click on this slide. All right. Yeah. So this is how we have come up. Muthu, you can go on mute. I can. There's a lot of.
So somebody else is presenting.
Ma'am, could you just see that? We can see. Someone else is also presenting, it seems. All right. Now it's fine. Muthu, again, I lost you.
Yeah. So I think someone is taking over the presentation, so that's the. Yeah, now you're on.
All right. Sorry, guys. Okay. So initially, we started in the year 2008 till 2004. We were Sosaley like 1.0 company. So we were more focused on the telematics and fleet management. Wherein like in today's scenario, you guys would be using this GPS tracker in place, right? Like so, we developed a decade ago itself, like in 2008 itself, and that's how we started this company. And then it got sold to a different company. So still we are a part of Sosaley, and we ventured into another segment wherein it's from 2013 to 16. So we started focusing on IoT and cloud space. So which is more of like now you guys been using this wearable items and other stuff, right? So similarly, we used to work on. And 3.0, like we just decided, okay, let us make some product in place, and then we started developing it. So wherein 4.0 is our new segment, like we started focusing on the engineering services activities too. So we don't restrict ourselves working only on the product development. So we also work for customers across the globe. So wherein like we have customers spread across in US, Europe, Australia, and all across the globe, I would say typically. So you can move on to the next slide. So coming back to this company, right? Like it was being founded by Mr. T.S. Varadarajan, and he was part of. He's the first student who had come out from IIT Madras. So he has like almost 3 decades of experience, and this is his product based company wherein like we have seen a very good growth and scope in the company. So you can move on to the next slide. So coming to our, oh Muthu, I lost you. All right. So coming back to the segment, the industry verticals, what all that we develop and design is like more of like healthcare industry, battery management system. Again, on the server side, we work on the embedded software and projects, and also like we used to do customization for different industry verticals. So this is our strength, and we have almost like 100 plus employees working in our organization, and we have been based out of Chennai, Velachery. Next slide, Muthu. Muthu, can you move on to the next slide?
Uh,
Okay, I cannot see that though. That's fine. Like, so we primarily, I mean, like
so
these
the
are
partial.
the, yeah, so these are the named customers who we have been working with, like all top-notch companies in India. So our idea was like when this company was started, right? Like we predominantly wanted to help Indian companies, and so that's how we developed ourselves. And so we are one of the market leaders in the space of IoT and medical electronics. So that's how our company got branded, and then it went to the international market. So next slide. So coming to our engineering services capabilities, like we do right from the scratch till the product development. So most of our customers, they come to us with the concept. So we help them to write right from the architecture level until the concept. Like concept is like we give them the complete solution, and then we take it to the production. We design, develop, and then it goes to the production. So we also ship some products to international companies too. Muthu, I think Karthik, you can take over the next slides.
You want to talk about BMS and then give it thick?
Yeah. So in today's scenario, right, I cannot see your slide, Muthu. I think it's not coming up. I don't know. Is the problem only for me or rest of us can also not see? I'm not sure. All right. So we have a product called BMS, which is a battery monitoring system. So typically, it's been used for all the industry verticals, and today it's one of the. It has a major role been playing with all the IT industries, any segment that you take, right? Like it can be an IT industry or automotive or whatever it is. Like it's playing a major role. So, wherein like in today's topic, we are just going to cover only on the medical electronics. So I don't want to take much time on this. So next product, what we have is like, so this is one of the product which we own, battery management system. Next one, Muthu. So this is a wireless ECG product.
Yeah.
Karthik, you want to talk? So Karthik is like he is
Yeah,
completely taking care of this
definitely.
healthcare product, and he is owning, and we all help him out to get a lot of connects. So that's how we have been here today. And since Karthik is one of the, I mean, ma'am's student, so Karthik, you can go ahead.
Actually, another branch which is we are holding is an healthcare products. So like it is like most of the make in India product. Like we have like a wireless CC, which is equal to the conventional model. We can see the events whichever the hospitals or clinical labs will be a bigger one. We need a special printer to take the printouts and all. This is an like innovative model. Like it will be like a size of a small box. We can take all the 48 ECG whichever taken in the conventional model. So this can be carried very easily, and the reports can be seen in the mobile itself. So the doctors who are at the colleges can like travel with the device. So it will be easy to take reports at any time. So these are indigenously in the Sosaley. So who is product owner is the Dr. Muthu. So next slide. So another product we have under development is the AED, automated external defibrillator, which is funded by the state government along with the collaboration with Anoop Prasanna. So this has been like it is just language based which is
Karthik,
fully automated.
you are breaking.
We can is it audible now?
Yeah, it's audible. I could see a lot of noise from your end, and the screen is also not getting. I mean, it's not broadcasting. It's very slow.
I think some network is there. Yeah.
All
So
right.
that's it. So like Muthu continue the remaining. So
All right. So, guys, apart from that, what
webinar
we do
topic.
is like, so we also help colleges. The reason why we inaugurate this webinar just because like we help a lot of colleges in setting up their IoT labs. So what we do is like we give complete solution for the colleges, like what experience that you get during I mean after you work, right, like after your college days you go to some company. So we give you a real time experience working to get a hands on during your college days itself. So we are supporting in that as well. So we will have a different separate session on it. So I can I'm just giving this I can handing over it to Mr. Dr. Muthu. Muthu, you can broadcast your screen now.
Okay. Thank you, Anoop and Karthik.
Yeah,
Um,
Dr. Muthu, hold on. Like,
so,
sorry about that. Like, so and I would request all the students to raise up their queries end of this session, and you can post it over the chat window. So we'll be able to answer it one by one. So this session is going to be for approximately another 35 to 40 minutes. So you'll be given like 10 minutes for your Q&A. Thank you, Muthu. You can go ahead.
okay. Thank you, Anoop. Thank you, faculty members of Shakthi Engineering College for arranging this webinar. Um, it's an opportunity to talk about some of the current and future trends of healthcare in India. Uh, so in today's agenda, so we have an introduction about the current trends and what are the regulatory things currently in India, and then what are the future trends or technologies which will. In nutshell, I will explain the products which we have developed in Sosaley. and some collaboration with reputed institutions. And then I will give you a use case. So many of you are students, so you would appreciate how what you learn at the university, how it is being used in the company actual environment. So that's how we will go through today. So the current slide, these are the major for healthcare product development currently in India. You can see that it is very much clustered in the south, and then in Gujarat, a little bit in Delhi region, and in Tamil Nadu, actually, if you take, there are companies like Roche, Vitron, others, and then Hyderabad has the Senju medical devices present. In Delhi, there are Boston Scientific's labs, etc. And in Bangalore, there are Johnson & Johnson, Philips, all R&D sense of Siemens, etc. are present. So, just for information, so these are the current development centers and companies which are working on healthcare product development in India. So, any interested, biomedical instrumentation related people can, contact these companies. So, what is the market for healthcare product in India? We are much import dependent, heavily dependent on import of medical devices. As you see, most of them are from China, Germany, and USA. And if you see the trade deficits or the trade balance, we are our export is very less compared to what we import in terms of medical devices. We export few of the medical and pharmaceutical and diagnostics to countries like USA, Singapore. But still, in terms of volume, we import a lot than what we export. So there are some numbers here, but the gist is that we are not self-dependent when it comes to medical devices manufacturing. And currently, both the central and state governments are putting forward firm steps together towards self-reliability, especially in medical devices manufacturing. From 2017, there was a government order which amends the existing Drug and Cosmetics Act, wherein they started notifying every medical devices as drugs. So every few months, once they are notifying one by one the medical devices, and almost 20 to 23 devices has been notified as drugs now. So this the Cosmetics Act and all Drugs and Cosmetics Act are now applied to medical devices also. So how do they divide? How they define medical device in the Act? So it's any device that is intended using internally or externally for the purpose of diagnosis or for treatment or mitigation of any symptoms or to prevention of disease, whatever, in humans or animals, they are all classified as medical devices and are regulated by the Drugs and Cosmetics Act, which is the body that what is called CDSCO, Central Drugs Control Standards Control Organization, CDSCO, and there are state level CDSCO. It's a state controlled drug and safety drug safety departments also. So some of the devices are controlled by the central organization and some the state bodies. Why is it so? Because they have classified the medical devices into 4 categories. So class A, B, C, and D. So class A have a low risk devices, small thermometers, starting from small thermometers, non-invasive, small devices. They come under class A, which are regulated by the state authorities. And from class B onwards, low, moderate risk, and then moderate high risk and high risk category of medical devices. They are by the central authority, and there are certain tests and certain permissions you have to obtain before you take the product into the market. So, what are the challenges that current manufacturers in India are facing? So they have to match up with the standards, international standards, and also they have to improve the devices for more accuracy in diagnosis, in monitoring and therapeutic capabilities. So more and more the companies in India now they are investing in research and development, and our company also do so. We are concentrating a lot in research and development activities. What are the trends trends that are impacting the medical device manufacturing? So it's can you see the slides? Is it visible, ma'am?
Yeah, Muthu. Now I can see.
Somebody who has taken over the presentation. So please, when you join, please make sure that you are not presenting so that it will not be interrupted. Thank you.
All right. So your screen.
So So talking about the current trends that is shaping up in the medical device manufacturing. So one is a lot of introduction of wearable health monitoring devices, and then there are fusion of technologies, combine technologies to provide advanced device, and then making scaling down the size, to be compact, to be able to carry everywhere, and then better. So India is now getting better at quality manufacturing. Changing that we also make quality devices, that can be sold in the world. And then we also have a little bit, not like Western countries, but still we have a problem of aging global population. And then there are new emerging markets that affect healthcare. And then in India, especially, there is a slow regulatory approval process which is hurting the manufacturer, because there is no clarity sometimes in whom to approach, what to do, etc., etc. So in terms of wearable health monitoring system, they have become a trend now. Even if it is not classified as healthcare devices, still lots of people now are using Fitbits and other fitness monitoring devices. That has become a very common thing. Then more and more also the health monitoring is also becoming like wearable devices. Where you can stick it to you can do your normal day-to-day activities, but and still have the device on you, kind of thing. So what are the challenges in making them? So there is always the challenge of scaling down, miniaturization. So you have to get components that fit the form factor, and it should not obstruct your day-to-day activities. It should not hinder your day-to-day activities. And then even in terms of in the even if it is still the sensing accuracy, the measurement should still comply to all the medical standards. In the name of miniaturization, you should not compromise on data acquisition. So, what are the technologies that will related to the wearable? It's like which will help this. So, flexible circuit, polymer materials. There need to be materials which help miniaturization of medical devices, and also power supply. So, when you go to such scale, powering up the device constantly is also a challenge. So you have to find power supplies that are the small but still can offer steady power supply. So, and to also towards this direction, you need more than one technology to be fused, because the traditional way of manufacturing will not help anymore. You have to, make the device more smart by introducing, smart materials available, MEMS-based sensors, batteries, which are in batteries which are smaller in size, etc. So, just a second. My presentation, is it not visible?
Yeah, yeah. Muthu, I think you can mute your. Sorry, Karthik, you there?
Yeah, yeah, I'm there.
Yeah, yeah. Please turn off your
So,
video
okay.
then. Mm.
Yeah. Um, so, so what are the technologies used in technology fusion? There is microjoining technologies and physical circuitry, and making power supply for small form factors, etc. And then same. So when you want to have implantable devices, there are more and more implantable devices now in the market. For continuous monitoring or to for diagnosis. So that means to have less impact or less discomfort for the patient. Uh, to miniaturize, so to have them less harmful for the persons using them. And then when the devices become smaller, when the devices become more advanced, there are fusions of technologies. Then the challenge of quality inspection also comes, because you have traditional quality inspection systems. You have the traditional way of checking for the checking of the devices. But now you need to be more creative, and you have to improve and adapt to the current trends of medical manufacturing. Um, and there is also a problem of aging global population. So that means you have to make your devices very easy to use. It should be less expensive, and sometimes maybe you have to design it to be able to adapt to in each individual, etc. So that's going to be a challenge in manufacturing sector. Markets emerging, there are combination devices and data intelligence, and also there is telemedicine kind of thing. So they have to have a low cost healthcare, and also it should be affordable to all people. For example, if you have a Ph.D. product, it will be really expensive due to the process that undergo that the product underwent. But now we have to make the standards a bit flexible for the manufacturers to be able to make them at low cost for third world countries, growing countries, developing countries. And then also in even in developed countries and in developing countries, there is a problem of regulatory approval processes being very bureaucratic, Hippocratic, and very slow. So the regulatory approval processes should be made more manufacturer friendly to adapt the fast growth in healthcare manufacturing. So also, what are all the evolving trends in terms of devices? So there are now more and more fee for value devices coming up. That means you only pay for what you really get from the device. You don't just the days are gone where you blindly buy devices by just suggestion. Nowadays, people value people evaluate the accuracy and the usage of the device, and only then pay for them. And also now there are companies that offer devices even for free, but you only pay for the test. So you pay for the results you get from the device. So it's not that you have to buy the spend much on the device. So you only spend for what you get out of the device. So that's a trend. There are a couple of already monitoring systems in India where you get the device for very cheap or either of no cost, but you pay for every test you conduct using that device. So there are a couple of examples. So there's a Centured medical device which detects early signs of heart failure, and then this system has saved an average of $10,000 because it prevents hospitalization, and also the traditional methods needs more testing, etc. So these devices give value for your money. And then there is Boston Scientific device Watchman, which is used for detecting medical blood clots, and it works 40% efficient than any blood thinner tablets that you take. And also then there is a now mixing of electronics and informatics, because even the big players, they are adding more electronics to get more information, and also they do analysis on the data and information you get from device. There is sharing of devices, there is sharing of data, and more connected devices are emerging. The standalone products are now being slowly getting phased out, because connectivity matters, and also data sharing, data analytics, and the trends you get from the data. Those are all playing a major role in current medical devices. For example, healthcare software Advantage, do a system called Advantage from Boston Scientific. It connects patients, healthcare providers, and there can be service-related organizations. All share one platform, remote monitoring using devices, and analytics on the medical records, etc., etc. And then more electronics being used in the traditional way of doing surgeries, treatment. There is a knee assessment, when doing a knee replacement surgeries, they provide more consistent and repeatable results, because they don't get tired, they don't get their repeatability is way higher than manual procedures. And what will be the medical device market in the next decade? So we expect it to grow around $500 billion. But the traditional medical products will have to phase out, and there is different business models coming in. More and more digital health solutions. Mostly, you don't have to buy the right now product as a service, as a service. The medical devices aspects like AI based predictability, everything will be now given as a service, and you can use, and you can only pay for what you use. Kind of trend will emerge soon. So even the traditional manufacturers of medtech products, they are now slowly moving to service-based offers. Even the established players are now moving their results and diagnostic softwares to cloud, so that you have connected multiple devices and a central platform, and there can be sharing of data, or there can be connectivity between different devices. So even big players in cloud like Apple, Google, Microsoft, they are creating platforms for medtech healthcare. So the connectivity, IoT based devices become more and more popular because we get support from industry giants. So this is some projections about the current trends of IoT and cloud-based medical devices, wearable devices. The global market was 4.5 billion in 2016, and end of 2020 it will reach by 12.8 billion, and most of them come from private cloud for for a private cloud for a particular platforms. People using it and then pay for what they use, and the segment is valued at 2.2 billion by 2016. And then actually the healthcare industry is one of the first industry to adapt to IoT very fast actually. The spending of healthcare in IoT solutions is estimated to be 1 trillion by 2025. Also the medical device, wearable devices and continuous monitoring systems, everything will be now cloud based in the near future. So the IoT and cloud-based devices throw lots of opportunities. At the same time, they throw a lot of challenges. If it's cloud-based, then you have more collaboration. You have a single platforms. You can have mobile apps for and you can do clinical trials and virtually at any part of the world. But then this brings a challenge because there is a regulatory approvals are different in different countries. There is FDA, there is EU, there is a Indian regulatory, and so when you work together at different parts of the world, then you have a challenge of having a common regulatory process for them. And then when you have always a connected device, you can get data in milliseconds, every millisecond. So that means you get a huge chunk of data, but you have to make use of it. You have to make something relevant. Information from the data. So you can have lots of trends. You can have lots of advanced analytics. But that also brings the challenge that of data security, because you need to be careful about sharing the data, because EU principles have very strict regulations on patient data. So it gives strict regulation. It gives strict guidelines on whom the data can be accessed with. So also the wearables and sensors, they offer lots of telemedicine possibilities, and they have good, good quality devices can be accessible to even rural region. But the thing is, there is no lack of a global standard, that regulates the connected medical devices, and there is no new. Protocols, wireless protocols, how the data is transferred, etc., etc. Because these IoT and cloud-based devices use a lot of wireless technologies, GSM, they use Zigbee, Bluetooth, etc. So there should be regulations that governs them. So even if you look the like Boston Scientific, Philips, Siemens, they are all, in spite of all the challenges, they are moving towards lots of cloud-based solutions. And there are big data analytics servers being bought by these people. And the other relevant trend is robotics. They are used in surgeries now because they are more precise, and once they are programmed, they do it repeatedly, and the reproducibility is very, very high. And also even now there are telemanipulation. You can sit at somewhere and then you can manipulate a robot to a procedure. And there are few types of robots, the surgical robots which are here, and there are also robots to disinfect the as operation and used by software robots which have pharmacy automation, ordering the pharmaceutical products and stock maintaining. Lots of automation going on. And then also there are rehabilitation robots, helping people who in ambulatories. And then there is also now technology advancement being used in medical learning also. Actually, education and training in especially in healthcare, when you need a hands-on training, that is you need actual present biological specimens, even human cadavers, etc., and sometimes live human patients. But now more simulation softwares have opened the aspect of being trained without actually having a biological specimen. So you will have the same look and feel, but you will learn the same procedure but without actual specimen. Unless you have trained at a level, then you can be allowed to do the procedure on the actual this will help in many ways. So it will less the crowding, because in most of the places you have access to only one or two specimens which all students have to access, and also in terms of homeland military situations also, they can be trained without having actual camera. So there are also technologies like virtual reality and augmented reality, where you can simulate simulate actual cadaver with all the touch and feel of the organs, and the pressure can be even simulated when you stitch the organs, when you do a procedure on a particular part of the body. Everything can be simulated with the touch and feel now. So that helps a lot for education and training in medical sector. So there are a couple of softwares. There are cadaver software. There are PC, which is to simulate simulate the distress of a newborn child, etc. And then another emerging, and which will be very prominent in the near future, is telemedicine. So telemedicine is anything that any medical related information obtained at one place or on a patient, and then it is transmitted via any electronic communication to improve his health status. It can be via video chat, it can be via smartphones, or any forms of telecommunication. So what are the advantages of telemedicine? So even the places which less accessibility to high-end equipments, they can be now connected. Because there can be a common platform where all the nodal medical devices can be connected, and then they can be connected with the physician instantly. There is a high cost efficiency there, because they don't have to get hospitalized or travel to hospital every time for any kind of checkup. There can be a telemedicine center where all tests can be done remotely, and then the reports can be interpreted by a physician sitting at anywhere in the world, actually. So what are the main components? Is there will be a telecommunication technology involved, and there will be a healthcare center where it can be assisted by a human or may not be even. This actually eliminate the barriers. And even the rurally located people, they have access to good healthcare system. So usually how it is, so either it is done by a video telephony. There will be a transmission of actual video images, or it can be a transmission of image records, or X-ray, CT, MRI records. And then if needed, some advanced diagnostic methods can be advanced diagnostic algorithms can be placed in a server, and then the application notes or the patient circuit can be anywhere in the world, and it can acquire data and do the analytics in a common server. And even in home healthcare, the telemedicine will play a very big role. And the advantages that telemedicine offers are the improved access, cost efficiency, improved quality, and patient demand. So soon, based on all these technologies, your smartphone will become a smart tool for medical research. Have all your records, all your medical diagnostic records will play smartphone itself, and it will be part of your diagnostic tool soon. So having talked about the trends, now what offers in healthcare vertical. So starting from idea to a product, idea to a solution, we give turnkey manufacturing, and also typing. We support in preclinical validation of a product, clinical validation, and software development, cloud enablement of your medical devices, etc. So now I will give an introduction to a couple of our products. So first one is an external defibrillator. It's a small sandwich toaster sized device which you can airports, etc., with a heart symbol on it. So it is used when somebody suddenly collapses with acute cardiac arrest. You need to revive him by giving him shock. So you place 2 electrodes on him and then give him adequate shock. So this one is fully automated. Compared to the current products available in the market. This was funded by Department of Science and Technology to Anna University in Chennai, and we developed the device for them. The idea was to make a low cost indigenous AED. So low cost indigenous, purely made in India. And it offers features that the current market products doesn't offer. Like we show the live ECG of the patient in this device, and then the device will automatically get the transthoracic impedance, and then it will deliver energy accordingly, and it will give time for CPR. It gives instruction in 3 languages based on GPS system: English, local language, and Hindi. Also, you can, after the procedure is done, take all records, ECG, the delivered in each cycle. Everything can be stored in a USB stick, and you can take it for future analysis. There is also storage inside for all these information. And also, the other department in the same Anna University has approached us for converting this device into a compact, lightweight device, so that it can be carried by a drone. Like ambulance, someone collapses in a app, his mobile, then he press app, and then the drone ambulance will reach him based on his coordinates with AED and emergency kits. So that's going to be a feature in emergency healthcare. Then we have another system which is a combined driver and truck monitoring system. So what we do is we attach an external small camera opposite to the driver of a truck, or place on vehicles where there are long runs of travels happening. So what it does is it takes images of the driver. There's a AI algorithm which will look at his eye blinks, yawning symptoms and everything, and it will calculate whether he is tired or whether he is fatigued. It's basically fatigue detection system. And if it better fatigue, it will give an alarm for him to stop the truck, and then also it will give the central command some notification. And also, based on IoT platform which Anoop was saying, we have a battery management system. We also add those parameters to this, so it will becomes both driver and truck monitoring system. So we can look for driver's sleep awake status, and we have a conductivity pad in the sheet in the steering wheel, which gives us the heart rate of the driver, and then combinedly you can based on these parameters. And then we have door close sensor to detect cargo tracking, and also for GPS tracking for for the trucks, and then related parameters, the voltage, current, temperature of the status of the charge, the status of the product, which we developed fully by Sosaley, is the device called Hot Tarang. It's a wireless ECG. So it's not like a Apple Watch ECG, where this one is a 12 lead fully medical grade ECG, but it is compact. It's in the size of a credit card holder or something. But the device is Bluetooth enabled. So what happens is you connect the 10 electrodes needed for 12 lead ECG, and you connect it to a port of the device, and then the device will send the ECG information to your smartphone. So Android based application has been developed. So if you open the application, so you can monitor each lead of the ECG like this. So this is a snapshot of our app. So you can monitor each lead one by one, and then finally you can also create a PDF report of the ECG, 12 lead ECG, similar to what you get from the hospitals. So you get in A4 size, which you can print it out. You can share it through digital platforms to your cardiologist. You can share it with anyone. This is the schematic. So we cure the ECG, we do some signal processing, and then transmit it through Bluetooth, and then the mobile phone Bluetooth receives the data, monitors it, and then if you create a report, it can be printed, it can be stored, have your patient details stored in the cloud, and then do analysis later. So to have a closer look at the device. So this is the device. So this is the 10 electrode cable that goes into the device, and then you have a mobile application where you connect with the device, and then your mobile phone becomes the ECG monitor, and it is very compact, very lightweight. It comes it can fit into a small purse. So the major applications for this is like there are people conducting medical camps in rural areas or anywhere. You don't have to carry a big device with you. This is very compact and lightweight. And then in ambulances, in emergency response teams, they can have this, and then when a patient is being loaded into the ambulance, they can connect this and send the ECG report to the doctor already before the patient arrives at the hospital. And then even small clinics, entry level general practice clinics, family doctors can use this, like they have stethoscope and other small devices, basic devices. This they can accure the ECG and send it to a cardiologist for further evaluation. So to just to have a relevance with what you learn at university and what we have used in this device. So you would have learned about signals and systems. So a signal is any function that conveys information about a phenomenon. In case of biosignals, it is biological phenomenon. So any biological quantity that varies with time or space is potentially a signal. So the significance with biosignals is it's usually in the order of millivolts, and it can be a bit noisy. and these biological signals continuously pass between various parts of the body. It can be created either as by electrical energy or molecular signatures. In case of ECG, it's electrical energy. So these biosignals are very much important in terms of diagnosis and also in further research of improvement of health of a person's health. So, for example, in the right side, I what each part of the ECG depicts. So the P wave it shows the depolarization activity of the atrial muscle, and the Keras complex shows the depolarization of the ventricles, and the T wave that shows the relaxation and the repolarization of the ventricles. So the signals carry certain information. So what happens usually, as I said, the biosignals are a bit noisy in many ways. So when we first designed it, we also had lots of ripples. You would have studied about filters in your subjects. So we also plan to use one of the digital filters to get rid of the noise we have. So what we chose is we chose a low pass finite impulse response filter, FIR you call it, of the lowest order possible, because we don't want to disturb the signal much. So the appropriate stop and pass band of the ECG signal is noted, because you should not filter the necessary frequencies, and since the noise we had was in form of a ripple, we used a equiripple method to elevate. And usually when you filter a signal, there will be a phase shift, so your signal will be out of phase with the original signal. So we use a technique of zero phase filtering, where the original and the filtered signal are in phase. So we actually the things happen inside the ECG device, which is embedded based systems. In real case, you cannot do the filtering efficiently. So what we did was we took samples. We took we analyzed the samples in MATLAB environment. We extracted the filtering coefficient from MATLAB environment, and then in real time in the embedded systems we effected actually a convolution with the filtering coefficient, which resulted in the filtering of the signal. You can see the unfiltered original waveform we had, and then after filtered, you can see the very clear ECG waveform. This is the current output of ECG app. So in terms of embedded system, you would have learned embedded system. So what the embedded system have is sensors or any measurement that is attached via an ADC, and it has a MCU microcontroller unit which does also all the processing, and then there will be output in many forms, as print, as or send it to a peripheral device, or send it to any display. In terms of IoT wireless based systems, what we have is the embedded system will use a module of either Bluetooth, Zigbee, or anything. So you acquire the signals, send it via Bluetooth to the smartphone, and then from smartphone you have an option of storing the patient records, patient details in cloud, so that you can anytime you can re-look at the records, do some analytics with the records. So the technology we used in the wireless ECG is Bluetooth Low Energy version 5.0 actually. So Bluetooth Low Energy operates at 2.4 gigahertz with 1.4 Mbps throughput. So it is basically for low power consumption. So it wakes and it's awake and sleep for fixed interval, so that it saves energy. And the range of the BLE device are typically 10 meters, and smartphones are usually used as a master to control and as a gateway, and then push the data to the internet. So why we use Bluetooth? Because it gives you interoperability, ease of use, interoperability in the sense you can have a common platform, many devices, a single software, or you can create API for a common platform. You can connect with the common analytical servers and many devices and a single software. And also, Bluetooth gives a certain extent of security for the data. So what happens? So adding wireless to a medical devices, what happens? It can be integrated into a ecosystem of medical devices. It can it can add flexibility to the user. And even the established medical devices can be converted into connected devices. Traditional devices can be converted into connected devices. For example, currently, Holter monitors, they use IoT, Bluetooth and Zigbee technologies in them. And then there are patches which monitor your temperature levels, oxygen levels, etc. And then there are chest straps, where it detects your heart activity and send to a smartphone app. So these are the technologies, and our device is also our device Cardiol also comes under such category. So if you are interested in such devices, what are the requirements for such devices? So you should have a sensor which is applied on the body, and then you need a analog to digital converters, because the biosignal is analog, but whenever you want to do some processing, transmission of the signal, it should be digital. And then you need a microcontroller unit. You need a display and you need a battery with a good battery life. In terms of project ideas in healthcare devices, in country like India, you can identify challenges, especially in terms of rural reach. We have a huge rural population in our country, and yeah, they don't have access to all the advancements in the healthcare products. So you can identify the challenge, and also there are elderly people who cannot use complicated devices, so you can make easy to use devices for them to use. And we can try to identify a small but inevitable problem. Don't go for a big project, but you can identify and fix small gaps in the healthcare system in our country. And there are lots of tools, hardware and software tools available, open source, cheap tools, single board computers like Raspberry Pi, Beagle boards, and there are lots of development kits released by the manufacturers of microcontroller units. And then there are open source development tools, and then there are repositories in GitHub, GitLab, etc., where you can get so much head start for your projects. And when you do a project at university level, you don't have to worry about the aesthetics, about the scaling down, miniaturization, because the idea, proof of concept matters. If you make it work, that's good, very much good enough. And also, at university level, looking at this and that, so you don't have to always find a groundbreaking idea at university level. So applications that are practical, applications that you have learned about what you learned in the university, that matters. And also, if it's possible to stay with the industry to know the relevance. You develop something that is relevant to the current situation, current trend. In terms of research prospectors, there are top institutions here, the CSIR, Central Electronics Engineering Research Institute, then IAC, IITs are there. And then in Anna, there is also a good opportunity here in Anna University where there is a national hub for healthcare instrumentation, NHHID. It is a DST funded hub. There are only two in the country, one in Anna University, one in PGI Chandigarh. They support a lot in in development of healthcare instrumentation. And then the state Apex universities, they are also doing a good research related to healthcare devices. There are DST funded laboratories that encourage a lot of research activities. You don't have to always expect a breakthrough research. Incremental research, is as good as any. Okay, so today, that's something I wanted to convey you, and I hope it was helpful. Thank you all for listening to the webinar. Thank you.
Thank you, Muthu, for your time. And students and professors,
Right.
thank you for participating. And we would request you to come up.
Yeah, yes, sir. Thank you, sir. Thank you so much. Your presentation is very nice and very useful for us. And everyone, you will must fill the feedback form. Once you will fill it, your feedback means you will get the e-certificates. Anyway, thanks for your participation. Thanks a lot.
Students, you have any questions or the professors? You can post it on the.
Also, we can answer the question anytime. They can route it to the university, the college, so that we can answer them at any time.
Okay, so I feel Muthu, everyone is good. Guys, so we are always available on all the social medias, and we are also personally available on LinkedIn. So you can keep us connected. Thank you, ma'am. Thank you for arranging this session. Have a good evening then. Bye.
Thank you. Have a good evening.